Welcome to the world of Internet of Things systems. Today we'll explore the fascinating field of IoT, focusing on how data is collected and processed to create smart and connected solutions. So, what exactly is the Internet of Things? At its core, it's a network of interconnected devices. These devices collect, exchange, and process data through the Internet. This enables smart automation and informed decision-making in various aspects of our lives. Let's take a look at the typical architecture of an IoT system. It's structured in layers. First, we have the device layer where sensors and actuators reside, collecting data from the environment. This data is then transmitted to the gateway layer, which handles data collection and transmission. Next, the data is sent to the cloud layer, where it's processed and stored. Finally, the application layer provides a user interface and analytics to make sense of the processed data. Now, how do we collect data in IoT systems? There are mainly two methods. The first one is sensor data collection, which involves gathering real-time environmental data from various sensors, such as temperature, humidity, and motion sensors. The second method is event-driven data collection. In this case, data is triggered by specific events or when certain threshold conditions are met. Communication protocols are the languages that IoT devices use to talk to each other and to the cloud. Some common protocols include MQTT, which is a lightweight messaging protocol, HTTP or REST, commonly used for web-based application programming interfaces, CoAP, which is designed for constrained devices, and WebSocket, which provides real-time bidirectional communication. Once data is collected, it goes through a processing pipeline. This pipeline consists of several stages. First, there's ingestion, where raw data is collected. Next, the validation stage checks the quality of the data. Then, transformation involves formatting and normalizing the data. After that, analysis is performed to detect patterns and insights. Finally, the processed data is stored for later use. Let's look at an example of how IoT data is processed using code. Here is a Python code. First, it imports JSON library. Then it imports datetime from datetime library. The function process sensor data takes raw data as an argument. The raw data is converted into JSON data. Then the data is validated to check the temperature. If the temperature is in between -40 and 85, the timestamp is added to the data and returns the data, otherwise it returns none. Cloud platforms play a crucial role in IoT systems by providing the infrastructure and services needed for data processing and storage. Some popular cloud platforms for IoT include Amazon Web Services, IoT Core, which offers device connectivity and message routing with advanced analytics, and Azure IoT Hub, which provides secure bidirectional communication and device management. Security is paramount in IoT systems to protect sensitive data and prevent unauthorized access. Some important security considerations include device security, which involves authentication and secure boot processes for IoT devices, data encryption, which ensures end-to-end encryption for data in transit and at rest, and network security, which includes secure protocols and firewall configurations. IoT is transforming various industries and enabling innovative applications. Some real-world applications include smart cities, which use IoT for traffic management and environmental monitoring, industrial IoT, which leverages IoT for predictive maintenance and equipment monitoring, healthcare, which utilizes IoT for remote patient monitoring and vital signs tracking, and agriculture, which employs IoT for precision farming and crop monitoring systems. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.